Okay, for this problem, we're being presented with two masses, M1 and M2, and they're being held together by the same rope on a pulley system. The rope has a mass of 0 and there's no friction. So we're being asked to find the acceleration of the first mass and the acceleration of the second mass, and then the tension for mass 1 and mass 2. So to begin with, we have to get the two equations that we're going to need to even tackle this problem. So the first equation that we're going to need is T minus M1G equal to M1A. And then we're also going to need, for M2, M2G minus T, since in this case MT is being pulled down by T1, T2, as you can see. And then we're just going to equal it to M2A. So we have two very similar equations. And then we know, because it was given to us in the problem, that M1 is 10 kilograms and that M2 is 100 kilograms. So now we can start working with these two equations. And the first thing we're going to do is try to isolate the acceleration so that we can find it. So we're going to have M2G minus M1G is equal to M1 plus M2 times the acceleration that we're trying to find. Now, if we move around this equation, we can get the acceleration M2 minus M1 times the force of gravity over M1 plus M2. And now plugging in the values that we're given, M2 is 100 minus M1, which is 10. And then for simplicity's sake, gravity, we can put it as 10 as well. And then we have 100 plus 10, the masses again. And then A will ultimately cancel out to being 90 over 11. After we've worked out everything, we end up with this. If you plug it into the calculator, and then 90 divided by 11 is 8.18. And since these two masses are being connected, they're connected by the same rope, they're going to experience the same acceleration, but they're going to experience it in different ways. So A1 is going to be a positive acceleration of 8.18 meters per second squared, while A2, which is the one having this force pulling down on it, it's having the tension of M1 pulling down on it, is going to experience negative 8.18 meters per second squared. And so that's how we get the acceleration. So now let's move on to doing the tension forces. And then just to keep it in mind, we know that the acceleration for M1 is 8.18, and then it's negative 8.18 for M2. So now let's do M1 first. To find the tension that M1 is experiencing, we have to do T1 minus M1G equals M1A. And then T1 will be minus the mass, which is 10, gravity, which is 10, and then the mass again, 10, times the 8.18. This is going to leave us with T1 minus 100 equals 81.8. And once we add 100 on both sides, we will know that T1, or the tension pulling on mass 1, is going to be 181.8 newtons. And now let's do mass 2. The second object, we can find it with this equation that we put right here, and then we have this equation for this one. M2G minus T2 equals M2A. And if we plug in these values again, we have 100 for the mass times 10 for gravity minus T2, because we don't know what that is yet, and then we'll have another 100, and then this time the 8.18 once again. We don't put the negative values because it will mess up the solution, but for now we keep it. 1000 minus T2 equals 818. And if we just move this around, subtract 1000 on both sides, we will see that negative T2 is negative 182. So T2 is 182 newtons. And these are the tension forces that are in this rope, in this pulley system.